Yeah, good afternoon. My presentation is about item parameter drifting and online calibration. Actually, I prepared two parts. My original plan was that I will present the first part, and my former student Rui Guo will present the second part. Unfortunately, she could not make the trip, so as a result, I have to present the both parts. So the second part, I'm not so familiar with that, but I will try my best. Okay, in my presentation, I just want to introduce what's the most current development in my lab at UIUC. And of course, all my students participated in the project. The first one is item revision in CAT. The second one is our students actually developed a cloud-based CAT multi-stage testing platform. Okay, this is for a language assessment called Chinese Language Proficiency Exam, HSK. And the third direction is right now we're so interested in how to use adapt testing to help adaptive learning. I think that topic is very closely related to our first speaker. Then the last part is about item parameter drifting and online calibration. Okay, then I would like to introduce the 11 students graduated from my lab from 2014 to 2014 to 2017, the 3 years. We graduated 11 students, and 6 went to university, and 5 went to industry. So they wrote their dissertations either in CAT or CDCAT or CD, something like that. So basically, if I have enough time, I would like to study their thesis and present one by one. Well, okay, now the first development is this is a foundation in CAT, a 30-year debate if the examinee should be allowed to review, to revise their items. Actually, in today's morning's presentation, Dr. Duanli Yan said so many bad things about CAT. So actually, I tried to defend CAT, but eventually I found so many people, raise their hands, ask a question. But actually, CAT is a wonderful thing. And of course, if you defend the MST, you don't have to say CAT is bad. Both are good, in my view, right? Well, but many people don't like CAT because many testing companies won't allow students to review the item. And once you turn to the next page, it's done deal. You cannot go back to review. The students feel very anxiety and increase the anxiety level because they realize if they made a mistake, they try to correct, but the system won't allow. So this is a very big debate. Of course, many people wrote papers and developed some methods to address this issue, including my friend, Chris Han, and he invented a very genius program. It's called the Pocket. And so I think solved the problem greatly. But Sui Wen, our student, what she did is to theoretically prove allowing students to revise the item during the testing can reduce anxiety not only, but also increase the reliability, reduce the measurement error, I should say that. And a few years ago, I introduced this result, presented. At that time, Sui Wen, she used a nominal response model for each item. If students tried once, tried the second time, tried the third time, these are all called data points. So at that time, Sui Wen, she used the nominal response model to capture all information. But by using nominal response model, some people like it, some don't, because nominal response model, you have to develop everything from the scratch, right? So the most recent, okay, now, according to the nominal response model, so eventually, Sui Wen proved mathematically the theta will converge to the true theta also the variance of the modified theta is approximately equal to the regular theta, something like that. So that means, okay, by doing this, we won't sacrifice our efficiency. But so what's the newest development? The newest development is that, that result has been generalized to the 2PL model. So that means originally she started with the nominal response model. Now it's a 3PL. It's a 2PL. But 3PL, you need to do some justification. When you estimate the theta, then instead of MLE, and in our paper published many years ago, we proposed something called modified MLE. Something like, because you need to set some boundary conditions to C, to A parameters, they are approximately very similar to the MLE. After then, okay, so everything will be under control. So this is a very interesting result. The second one is our students build a cloud-based computerized adapt testing system. That system, is web-based, and it's about Chinese language proficiency exam, which is the second largest language test in the world. Every year, about 500,000 students all over the world taking the exam. And so what our student did is to work closely with these content people according to their content specification. There are many of them. They have an item bank. Also, we used several item selection rule, and also, we control these specifications so carefully. So eventually, after this experiment, after they are hard working, so eventually like 1,000 item bank, the item pool usage rate can be as high as 99%. Almost every item can be used. Okay, something like that. So that system will eventually be used by the end of the year. Okay, so deliver the HSK. HSK is very popular now, not only in China, in the United States, in the South Korea. Many countries, people are taking this exam, something like TOEFL, okay, the Chinese version of TOEFL. So I am so pleased because this system, was developed by a group of graduate students. So not only we developed the software, we conducted the simulation by using R package, but also, we put this system to the web by using Python and developed a platform, developed a diagnostic platform, also database. So that means the CAT now, I think, unlike many years ago, the implementation of CAT can be as easy as just write paper pencil test, something like that, because the technology is ready. So that's the reason I think the future of testing is web-based instead of intranet-based. Should be cloud-based. Okay, we rent Amazon's cloud computing, okay, with reasonably this fee charge. So I think everything is fine, okay. Yeah. Stop. What happened? Oh yeah, that's the end. And another thing I want to say a few words about is about new application motivated by adaptive learning. We recently received the NSF grant. This is about helping some students learning some difficult classes like physics, maths, algebra, and instead of by using computer to teach students, we just help classroom teaching. So we develop some item bank, and we use CAT model, cognitive diagnostic computerized lab testing. And then, we encourage students who could not do well to practice with the data bank, with the adaptive testing system every time they receive some diagnosis report. So at the end of the semester, found those students who participated all had reasonably good results, something like that. Okay, because of the time limit, so I will move to the second part. The second part is about item parameter drift and online calibration. That was a doctoral thesis of a student. Her name is Rigor. And the reason we studied this together, one is item parameter drifting, the other is online calibration. I think that they are two closely related problems. Item parameter drifting means that if you use the item for many, many months, okay, then you find that the item parameter has been changed because for all kinds of reasons. Probably, the item's information become known to many students, or whatever the reason, the item parameter has been changed, then this item should be deleted or should be, something like that. But that should be, detected by a statistical procedure. Well, the second one is called online calibration. Online calibration in computerized data testing, the most important part is what about item parameters for your next test? Of course, we can do this by using online calibration. When students took the exam, we can embed this. We could embed these items into exam. Okay, and the methodology, of course, online calibration, the methodology will have optimal design, we have two-dimensional item response theory model, and we try to do this, because many people have already written paper about unidimensional situation. So our goal is try to explore this in two-dimensional situation and invented some new methods called four-quadrant optimal solutions. And also she did some simulation and found some interesting results. Well, in that part, first we need to understand what's the issue in item parameter drifting. And then item parameter drifting in paper pencil test, usually people do some linking. They just re-estimate item parameters, then they try to link the recalibrate item parameter with the original item parameters, then try to identify if item parameter has been changed. There are a couple of procedures are so popular, but many procedures are based on on individual item detecting. Ray Guo, and she developed a procedure by looking at test characteristic curve. Because the idea is if you have a couple of items have item parameter drifted. Probably some are positively drifted, some are negative drifted, but ICC curve will remain the same, the scale remain unchanged, right? Okay, that part, she published this paper in JEM, but in our program, we have a very rigorous, program, and publish one paper, you cannot graduate, at least 3 papers. You combine 3 papers as one dissertation. So that's the reason, I encourage her, why don't you look at two-dimensional situation? That is what she did. Of course, here are the 3 methods. It's a log chi-square test, like a ratio test, and a stepwise test characteristic curve method. That was reinvented. Something like, if you have 2 TCC, test characteristic curve, and you have 2 sets of items you have suspicions they have a parameter drifted. And in order to detect which item really caused a drifting problem, just like stepwise regression, dimension reduction, you reduce 1, kick out 1, and sometimes kick out 2, sometimes bring a 1. So eventually until the procedure stabilized. So I think this is very interesting. But what I will introduce is about in multidimensional detecting and how this problem can be related to online calibration. Okay, well, in that situation, we need to define a sample size. Not all items receive enough sample size, and that means you cannot use the traditional method. You have to use online calibration methods to detect item parameter drifting. And so like linking the traditional way, you just link the item parameter from the new scale to old scale, then compare the item parameter to see if they are identical. That method cannot be used straightforwardly in computerized step testing. So that means we need to use CAT technology. In CAT technology, and you divide the item pool into two parts. One is called operation pool. You assume these item parameters have already known. The second pool is called the calibration pool. So these are the item parameters you try to calibrate from the testing. So you divide the test into two parts. One is called operation test. The other is a calibrate test. Or you can say recalibrate. If this is item parameter drifting, then you call it recalibrate. Okay? So this is the data structure. Data structure then, for the recalibrating, of course, you need to design. You need to design something like pre-recalibration. So how can you do this? You just send this item to the students to get some approximate item parameters. And once they have approximate item parameters, then you can assign them to the students accordingly, according to their ability. Of course, you have the seeding location, you have estimation methods, how the theta will be estimated, also termination rule. There are so many details in this direction. There are a couple of selection methods. Here, we need to have a very brief introduction. One is called the random selection. I think many testing companies are doing random selection. So that means you just randomly assign few items to each student. The second one is called the examinee-centered adaptive selection. That means according to the student's estimate ability, I try to assign appropriate item to this student. So this one is the most popular method. Okay, but this method is not good for 2PL model because in the 2PL model, you can mathematically prove a parameter cannot be identified. Why? Because you use a very homogeneous group of students to estimate that then B parameter can be appropriately estimated, not A parameter. So that's why some people proposed here Chen. Her first name is Ivan Chen. He is currently a professor at Taiwan, in Taiwan, a very like a national institute of research. And he proposed this called two-stage design, called item-centered. Item-centered means that, for each item, I know its item parameter assumed. Then I try to identify two groups of students. One is lower, the other is upper, high, right? And then just sample these two groups of students. So in that way, the item-centered method is of course much better than examinee-centered. Of course, if you only use Rush model, then examinee-centered method should be fine. Well, in that unidimensional situation, we have two-stage design. That design was introduced by Ivan Chen and his student. And also we have a suitability index design. That method was proposed by my former student, Usama Ali. He is now a research scientist at ETS. The third method, is called multi-dimensional situation, MCAT, introduced by Sitt and Torsley. And it's the ultimate design. Of course, some people like Dr. Dell and von der Linden, they made some unique contribution. They just proposed something refinements and try to make this operationally friendly. And they are almost something like that. But operation CAT, first you have operating CAT, and then according to the Ivan Chen, what is the best for the 2-point optimal? Okay, it's like lower the 17.6 percent, high 82.4%. So if you sample students, in two-peer model, and he is very mathematical. He made some mathematical proof published in Annals of Statistics, also published paper in psychometric. Then his result is you should sample the students, one is below this point, the other is above that point. In so doing, I think A parameter, B parameter, both A parameter, B parameter can be very precisely estimated. So this is very, very, very good. Of course, the second one is Ali's method called the suitability method. So you divide this interval into several sub-interval, then you just do the multiplication for each F, and this is the total quota. This is how many items have been selected. And also here you have to multiply a weight. Here is estimate B, estimate theta, something like that. Okay, this one is very user-friendly because you only do multiplication and counting, right? You can do that, but the key is how should you identify the weights? Okay, there are so many different ways, so I will not introduce that. Now, our goal is to look at this problem in the two-dimensional situation. If two-dimensional is okay, then probably we can generalize to three-dimensional, right? So in two-dimensional situation, and Sitt and Torsley, they proposed a method. Their goal is for any given item service, and we should be only focus on these two regions. One is the probability. From the probability, the answer item correctly, the probability should be greater than 0.1 and less than 0.9. Okay, we should, the idea is we should only take a certain region. Okay, and then, of course, according to this, and you have to decide the region where you sample the examinee. But in one-dimensional situation, it's so easy, right? You have 2 points, but now it's a two-dimensional situation. You have a region, you have a plane, and where the theta should be, the vector theta should be selected, and then they have already proposed the 4 points design. 4 points design, it's the optimal design. Okay, of course, if you don't do that, you can always do de-optimality. De-optimality, then what's the problem? The problem is examinee-centered, it's not item-centered. Now, we are more interested, we try to explore what is a good way to do item-centered method. According to the item, I try to sample examinee so that this group of examinee can give me the best result, something like that. I think that this direction is very interesting. Then, of course, this sampling mechanism is related to the item pre-estimate item parameter. Suppose we have a two-dimensional situation, compensatory model, B equal to 0, A1 equal to 1, A2 equal to 2. In that situation, according to 4 points design, the 4 points design, the optimality. So you will find that there are 4 lines. The intersection of the 4 lines actually are 4 designing points. That means you need to sample from this close to these 4 points. Okay, but the problem is what? According to this figure, only 2 quadrants. The only 2 quadrants examinee can be sampled, but not this part, not that part. But students' ability, suppose the 4 quadrant, every quadrant should have the possibility, right? So that's the reason, and we introduce a new method. That new method is 4 quadrant method, means we force the sampling points to each of the quadrant. Okay, so of course, if you have the model here is the item response surface. And the idea is where to sample examinee for the given the samples. So, I think this is interesting. So eventually, I think if we can get some theoretically interesting results, then eventually we can do something sampling, stratification, right? But at first, we need to get something mathematical. So of course, mathematical, you have item information matrix. Item information matrix, you have P, you have Q, then theta square. According to this situation, under this situation, you can derive this. You can derive. Also, by mimicking this 4-coding design, we have 4 points. 4 points, under 4 points design, so eventually the information matrix, can be written as this one. So calculation should be very straightforward, right? And then the 4 codings, each points, obviously the 4 points now are indeed in each of the 4. Also, remember, it's a 2-coding design. 2 codings design, you need to, it's symmetric. But 4 codings is still symmetric. You just draw a 1 line, second line, this point and that point symmetric, this point and that point symmetric, right? So, yeah, I think because I don't have enough time, I will go through very quickly. So, eventually, she did some simulation. And of course, there are many derivations, but these derivations, I should say, straightforward. According to this condition, okay, this. And also, in Ivan Chen's solution, if you have 1 point, sampling from the exact same point, probably it's mission impossible because students take tests. It's not simultaneous. Some students take yesterday, some students take tomorrow, right? So that means we should give students a region. So in a 2-dimensional situation, according to the distribution, if 0, and then, the item should be close to this R, so within that distance, all the points is possible. But in the 2-dimensional situation, if we have 2 points, then we can do this, by doing this within this circle. Okay, of course, just calculate the radius, and then we need to sample that. Of course, in a unidimensional situation, we can calculate this D, but for the 2-dimensional situation, just by doing the Euclidean distance. Okay, so that means for every point, you have a distribution. This distribution is about theta distribution. And then we just, according to this, we can determine which point to sample the examinee, something like that. Okay, so I think the result is very encouraging. The results is not that perfect, but it's very encouraging. That means the method that she invented generated smaller mean squared error, and also bias are smaller. Also, when detect these drifted item, the power is very high. The highest power, but unfortunately, type 1 error is slightly inflated. Of course, this is only the first step, so we are still working on it. So eventually, the idea is, instead of all the derivation, eventually we try to make some kind of empirical methods, like a stratification and sampling mechanism. So eventually, we can do this, This is so-called item-centered method in the 2-dimensional situation. Okay, thank you very much. We have time for one question. Yes.
Yeah, I have a question about your first part of your presentation. First of all, it was very good to see you pulled off the large scale application of the camera HSM. So you strongly suggested that the test system should be implemented on cloud as a secure test. I can see what kind of benefits you can get out of the cloud-based test system. For example, the computer, item exposure control can be actually now done in real time because you now have item usage data real time. You don't need to make a guess using conventional method, for example. Is there any advantages you can also list or introduce by using cloud-based system comparing to server-based or other?
The real problem is just by looking at the ETS. ETS acquired a company called Prometric. Now all these equipment are outdated. They need to spend money to hire many people to do the maintenance. But if you do cloud-based, don't worry about it. Yeah, something like that. Also, in Shanghai, in Beijing, many students, they try to take TOEFL, but the seats always limited. Because Prometric, they only have like 50 seats in each city. So it's inconvenient. Now, laptop is so cheap, right? You can, because it's cloud, I think it will convenient. So I think, that is why cloud-based will be. But it's also so fast. We found it so fast. No matter how fast the machine you are using, you cannot compete.